got this!
Hey everyone, my name's Emma.
I'm Drew.
I'm Logan.
I'm Kat.
I'm Shemaya.
And we are Group B. Today we're going to walk you through some cool experiments we did this semester in 321.
But first, let's put on our personal protective equipment, or PPE.
And now that we have our personal protective equipment on, we're ready to go to the lab.
Before you start the experiment, make sure to read the safety data sheet located in every lab, or electronically. And make sure you wear gloves. First off, we're going to start off with experiment 1, the measuring of viscosities and densities of different oils at different temperatures. First off, we have our viscosity measurements using our Zahn cups at different oils in different temperatures. The oils are in water baths and they're at different temperatures. Remember, for the Zahn cups, specific ones work for specific trials better than others, so play around with the Zahn cups. If you used it previously in one trial, maybe redo that trial with a different Zahn cup so you can have it later down on the line.
Hey, don't listen to the oaf on the screen for a second, but here is the analytical balance used in determining the oil's mass, which is then used to determine the density for the oil, which the only thing you got to note is make sure the scale is zeroed before use. And then a quick note about the lab, the breakpoint of each trial's Zahn cup measurement is difficult to find, so just could be consistent across all trials and then run multiple trials.
Yippee!
A quick mention on teamwork. Notice how some of them are doing one task while some of them are doing other tasks. This is very important in the lab. Have people doing different things at different times to ensure quick and timely lab experiments.
We got a #1 victory royale. Yeah, Fortnite, we bout to get.
Also, remember, if you don't know something, ask a TA. They're the foremost authority of most things, and they're pretty damn smart themselves.
What's up, I'm Kat, and welcome to the dye absorption lab. Come on. First things first, you're going to want to make sure that you're familiar with any technical equipment, such as the UV-Vis spectrophotometer. This is going to measure the absorbance and curate our calibration curve. Whoa, hold on a second. What are you doing here? This is something you do not want to do. Having multiple cuvettes in there can cause errors in our calibration curve. You only want to do one at a time. Another thing you're going to do is make sure that the cuvette is facing the right way, which is something you didn't do. This is going to have a little arrow mark right here, and you want to make sure that this is facing towards the monitor so that it's getting an accurate depiction of what's going to be in the cuvette. For this lab, you're definitely going to want to divide and conquer. We have a lot of cuvettes, a lot of samples to take, and then a lot of UV-Vis scans to take. The suggestion is having multiple people working on different conditions or having one person work on each condition. What we did is we had a couple people working over here collecting samples, and then we had 2 people over here by the UV-Vis machine collecting those samples at the same time. We took samples every 3 minutes to see more of a change in the initial saturation. Because of this, you're going to want to work diligently and quickly. Some of the errors we had was we saw a lot of wool in the cuvettes, so just be careful when you're pipetting them. Also, make sure the wool is fully submerged and perhaps consider using more string than just 6 inches to allow for more absorption.
Come with me for experiment 3. This is salt dilution through a series of stirred tank reactors, or CSTR. For this experiment, you will fill every CSTR with the water, DI water. Make sure somebody knows what every switch does. Having somebody make the stock solution when you first come in is very time effective. Once the stock solution is made, somebody will then be doing calibration curves with the probes. While the calibration curves are being made, somebody needs to make sure that the system reaches steady state before any flow measurements are taken. This part can take a lot of time, so make sure to get on that stat. An important part of this experiment is that we split up tasks. Somebody, when you start the dilution, needs to be paying attention to the timer. Do not miss any measurements during all these trials, or you will have to start over and it will not be good.
We slaying it, never quit. Slaying it with the grit.
One error we had was having dye in one of the trials. Don't do this. Keep it consistent through all of them. This lab is very time consuming, so be very quick with changeovers. Make sure you soak all of the salt out or it's gonna mess up your calibration later. Don't do this.
Oh my god!
Overall, keep clear rolls, stay on top of time, and reach steady state as soon as possible.
Wait, guys! Something's wrong.
Is it me?
Oh no.
Has the West fallen?
No.
Did you fail your separations exam?
Well, maybe, but no. We forgot our hard hats. Much better. So this lab focuses on pressure loss in a piping system and the influence of different valves. And there are a few things you want to keep in mind, so follow me. So with this lab specifically, it's important to have two people on the inlet pressure and outlet pressure. The individual on the inlet pressure should be opening and closing the valve. It's also important to have someone taking notes of the inlet and outlet pressures. Also important to keep in mind to hold the hose with two hands and to ensure that the head of the hose does not come into contact with the water, as that will mess up your reading.
My granny calls you said Travis, you work too hard. I'm worried you forget about
Ball,
me.
ball.
I'm falling in and out of clubs. Don't worry, I'ma get it. My granny calls you said Travis, you work too hard. I'm worried you forget about me.
Ball.
I'm falling. Wait, actually, this
Maybe
probably.
right here I think would be. So as I mentioned earlier, an important part of this lab is making sure that you know the difference between the globe, gate, and needle valves. You can always ask your TA if you need clarification surrounding the different kinds of valves, but it's very important to be able to distinguish which valves are which in order to have proper data analysis. Another important thing to note with this lab is to use the ball valves. These are ball valves, right?
Ball.
Okay.
Ball.
Another important thing to note with this lab is to use the ball valves to isolate the different lines depending on what part of the piping system you're looking at. And they operate pretty simple. Like that.
Do you want to come over?
Yeah, I was gonna say maybe. Also make sure to put the water in the drink.
This is the experiment for heat transfer around spheres. And so here, the pro tip when using the bath, heat the bath hotter than the temperature you want the balls to be at to speed up the heating process. Otherwise, this experiment is going to take too long. But be careful and don't heat up the bath too hot. And then over here, we have the anemometer and where you will be cooling the ball with the fan. Ensure that the anemometer is working properly and check with the TA. Additionally, remember the fan speed that you choose. And ensure that the anemometer and the ball are both the same distance from the fan for each trial.
Wow.
You also must ensure that you insert the thermocouple as far as you can into the sphere to get the most accurate data. When working the computer software, make sure to start each trial at the desired temperature you want the spheres to be at, and be careful when naming your trials so you know which one is which. And don't forget to bring your flash drive. In this experiment, it's important to identify the metal that each sphere consists of. To make sure you know what it is, you can do a density calculation by measuring the weight of the sphere and then putting that over the volume of the sphere. You also can ask the TAs about which sphere is which metal, but sometimes they don't always give you the answer. And then you also need to make sure you're using the right scale when doing the measurements, because some of the scales produce an error when you put something on too heavy.
We would like to extend a very special thank you to Dr. Espahani for his mentorship throughout the semester.
And the TAs.
Conair.
River.
Thanks for watching. Bye.
Sweet home Alabama, oh sweet home.